So now we are in chapter 7.6 and we're going to be solving rational equations. Our first objective is to solve a rational equation. So a rational equation, also called a fractional equation, is an equation containing one or more rational expressions. The following is an example of a rational equation. Notice that we have a fraction expression equal to a fraction expression minus another fraction expression. That makes it a rational equation. Also, with rational equations, you could see the variable in the denominator. So, when adding or subtracting rational expressions, we find the least common denominator and convert fractions to equivalent fractions that have common denominators. By contrast, when solving rational equation, the LCD is used as a multiplier that clears an equation of the fractions. So all this is saying is in order to remove the fractions, you are going to multiply every term by the least common denominator, so the LCD. So again, to remove the fractions or the denominators, you're going to multiply every term by the LCD. And steps for solving rational equations. Step 1, you're going to list any restrictions on the variable. Remember, you want to avoid dividing by 0. So any x value that will give you a 0 on the bottom would be considered a restriction. So you're going to start by listing your restrictions. And then step 2 says you're going to clear the equation of fractions by multiplying both sides by the LCD. So every term is going to be multiplied by the least common denominator. And then step 3, you're going to solve the resulting equation. And then step 4, reject any proposed solution that is in the list of restrictions from step 1. Check other solutions in the original equation. So let's practice some. So we have 7x minus 4 divided by 5x equals 9 divided by 5 minus 4 over x. Well, the first thing we're going to do, off to the side, we're going to list the restrictions. So look at each denominator. This one says 5x. So I'm going to say 5x equals 0. So, solve for x by dividing by 5. So you're saying x equals 0. You know what? I'm going to say cannot equal 0. So this is one of our restrictions. X cannot equal 0. This denominator is just 5. That's a number. We're fine there. And this one is x. So over to the side, we're going to do the same thing. X cannot equal 0, which means our only restriction is x cannot equal 0. So that's step 1. Now step 2 is to multiply every term by the LCD. Now take a moment, figure out the LCD, and hopefully you come up with it being 5x. So the LCD is 5x, so I'm going to multiply everything by 5x. Remember, when you multiply by the LCD, you are clearing out the denominators. So make sure you are simplifying before you start multiplying across. So we're going to multiply every term by 5x. This is a term. We're going to multiply this term by 5x, because it's also a term. And we're going to multiply this term by 5x. For the first one, the 5x cancels out, and we're left with 7x minus 4 equals, well, the 5's cancel out, and we have 9x minus, the x's are gone, and we have 20. So now we have 7x minus 4 equals 9x minus 20. Let's solve for x, which is step 3. So I'm going to subtract 7x on both sides. And I get negative 4 equals 2x minus 20. And then let's add 20 on both sides. And we have 2x equals 16. And then last, divide by 2, and we have x equals 8. Now, before we can say that is our solution, we have to look back up at our restrictions. And the only restriction we had was x cannot equal 0. Well, 8 isn't 0, so 8's good to go. Now, if you further want to check or verify that this is your answer, you come back up here to the original equation, and everywhere you see an x, plug in an 8. And the question is, does the left side equal the right side? If it does, then this is verified as a solution. I'll leave that up to you to do. Verify that x equals 8 is actually the right solution. And we're going to move on. Alright, so we have another one to solve. This time it says 4x divided by x squared minus 25 equals 1 over x plus 5 minus 2 over x minus 5. Well, the same thing, we're going to list our restrictions. And we're going to start with the first one. Now, before I start here, I am actually going to factor this. So this is x minus 5 times x plus 5. Okay? Remember, factor if you can. Now, or set the first one not equal to 0. Let's solve. So remember, the zero product principle still applies. So we're going to say x minus 5 cannot equal 0, and x plus 5 cannot equal 0. So x cannot equal 5, and x cannot equal negative 5. If we look at the other denominators, we'll see that we actually have those results already here. X plus 5 cannot equal 0. X minus 5 cannot equal 0. So these are your restrictions. You have to be careful. Then step 2 is to find the LCD. So take a moment, find your LCD, and hopefully you get it to be x plus 5 times x minus 5, or you can switch the order and say x minus 5 times x plus 5. Once you have the LCD, you are going to multiply each term by the LCD. So we're going to multiply this term by the LCD, which is x plus 5, x minus 5, as well as this term, x plus 5, x minus 5, and the last term, x plus 5 times x minus 5. So for the first term, these cancel out, and we're left with 4x equals, well, the second term, the x plus 5 cancels out, and we have x minus 5. And then we have minus, I'm going to go ahead and write the 2 because I know he's there. The x minus 5's cancel out, but the 2 has to be multiplied by x plus 5. Realize that 2 is multiplying everybody inside this parentheses. So really we have 4x equals negative x minus 15. Verify that you also got the right side to be negative x minus 15. And then we're going to solve for x. So I'm going to move over a little bit. And we have 4x equals negative x minus 15. Add x on both sides. Add x. Now we have 5x equals negative 15. The last step is to divide by 5, and we have x equals negative 3. Now before we can say this is our solution, we go back up to our restrictions, and do we see a negative 3 there? We do not. Therefore, this is our solution. You can further verify that this is your solution by coming back to the original equation, and everywhere you see an x, put a negative 3, and verify that you actually get the left side to equal the right side. All right, another example for us to work on. So now we have 3x plus 1 divided by x minus 4 equals 6x plus 5 divided by 2x minus 7. So the first thing we're going to do is set the denominators not equal to 0, and we're going to find all of our restrictions. So we have x minus 4 does not equal 0. And we're also going to say 2x minus 7 does not equal 0. Adding 4 on both sides, we're going to have x does not equal 4. And this will come out to be x does not equal 7 over 2. Add 7 on both sides, then divide by 2. These are our restrictions. So once we have our restrictions, we're going to go over now and find the LCD. So again, take a moment, find your LCD, and hopefully you got it to be x minus 4 times 2x minus 7. And you're going to multiply every term by the LCD. So this is going to be multiplied by x minus 4 times 2x minus 7. And this is going to be multiplied by x minus 4 times 2x minus 7. Now the x minus 4's cancel out, but we still have 2x minus 7 times 3x plus 1 equals, now the 2x minus 7's cancel out, and we have 6x plus 5 times x minus 4. Now we need to solve for x, so we're going to have to FOIL. So I'm going to FOIL and you FOIL, and let's verify that we get the same thing. Okay, so we have 6x squared minus 19x minus 7 equals 6x squared minus 19x minus 20. Let's solve for x. So we're going to subtract 6x on both sides. Doing that will force these to cancel. And then we're going to add 19x on both sides. Doing that forces these to cancel. And we're left with negative 7 equals negative 20. Now, that's not possible, so that's a not equal to, which means our solution is really no solution. And this basically means it does not matter what you plug in for x, the left side will never equal the right side. Okay, another example. So, the first thing we need to do is go ahead and factor this. So let's factor this. This comes out to be x plus 4 times x minus 2. Now let's list our restrictions. So we're going to say x plus 4 cannot equal 0, and we're going to say x minus 2 cannot equal 0. Which means x cannot equal negative 4, and x cannot equal positive 2. Then step 2 is to find the LCD and multiply every term by it, where our LCD is going to be x plus 4 times x minus 2. And then we're going to multiply every term by the LCD. Okay, so now let's simplify. This cancels out completely. That cancels out completely, and we have 2x minus 1 plus, well, I know that 2 is still there, so let me write it. The x plus 4 cancels out, and I have x minus 2. And I realize that 2 is going to multiply everything inside this x minus 2. And then equals, well, the x minus 2 cancels out, and we just have x plus 4. So this becomes 2x minus 1 plus 2x minus 4 equals x plus 4. Combine our like terms, and we have 4x minus 5 equals x plus 4. Subtract x on both sides. And now we have 3x minus 5 equals 4. Add 5 on both sides, add 5. And we have 3x equals 9. Divide by 3, divide by 3. X equals 3. Now remember, let's go up to our restrictions. Do we see anywhere where it says x cannot be equal to 3? We do not. So x equals 3 is our solution. You can double verify it by taking it back into the original equation. And everywhere you see an x, make it a 3. And verify that the left side equals the right side. Okay, so some important notes to remember. A common error when solving rational equations is to forget to check the list of restrictions. Once you have an answer, make sure that there wasn't a restriction on that value. Because remember, you do not want to divide by 0. Another mistake is another mistake is checking the solution in one of the equations that was part of the steps. You always want to check it in the original equation. And make sure always go to your list of restrictions to see if there is a restriction on your solution. Alright, objective 2. Solving problems involving formulas with rational expressions. So rational equations can be solved to answer questions about variables contained in mathematical models. Here's an example. It says the formula y equals 250x divided by 100 minus x models the cost y in millions of dollars to remove x% of a river's pollutants. If the government commits $750 million for this project, what percentage of pollutants can be removed? Now, like any other word problem, you have to first identify some things. So they gave us an equation, and in that equation we have some variables. We have the variable y. So come over here and you realize that y is what? The cost. So y represents the cost, and x represents the percent of river pollutants. So we're going to call x the percentage. Now we go back to the question, and it says if the government commits $750 million for this project, what percentage of pollutants can be removed? So what did they give you here? They gave you the y, and they're looking for the x. So we're going to start by plugging in the y. So we have 750 million equals 250x divided by 100 minus x. Now, you may be questioning, why did I just write 750 and not actually write out 750 million? Well, in the problem, it says the cost of y is already in millions of dollars. Therefore, you just want to put in the number 750. Basically, ignore this million. It's already been factored into this y. So now we need to solve for x. So remember that what's underneath 750 is a 1. And notice that you have an x in the denominator as well as the numerator. There's an equal sign in between, so we are going to start off by cross multiplying. You can cross multiply when there's an equal sign in the middle. So we have 750 times 100 minus x equals 250x. We're still solving for x. He's inside the parentheses, so let's go ahead and distribute. And now we have 75,000 minus 750x equals 250x. So remember, we're still solving for x, which means now we need to get our x's together. So we're going to do that by adding 750x on both sides of our equation. And we have 75,000 equals 1,000x. Finish it off by dividing by 1,000. And we have x equals 75%. So if you want, you can write it as 75% of pollutants. So even with word problems, remember the most important thing to do is to pull out the values they give you. Make sure you plug it in for the right variable, so you need to know what does each variable represent in the equation. Plug in the values in the correct variables and then solve for the unknown. And then make sure you write the answer back in terms of the problem. So we have 75% of pollutants. All right, last objective, objective 3. Now we want to solve a formula with a rational expression for a variable. Here's some steps. I'm going to let you read through this. The most important part is in bold. It says the goal when solving for a specified variable is to get that variable alone on one side of the equation. Regardless if there's other letters and other variables there, the variable you are solving for, you must get it alone on one side of the equation. So here's an example. It says solve the formula for R. And it says I equals E divided by capital R plus little r. And we're solving for capital R, big R. So let's first start here. Big R is in the denominator. In order for me to solve for him, he needs to be in the numerator. So again, what's underneath I? A 1. Here's that equal sign. So what do we do when we see an equal sign? We cross multiply. So now we have I times capital R plus lowercase r equals just E. And again, you're solving for R. And if you were normally to solve for a variable and it's inside the parentheses, what would you have to do? You would have to distribute. So let's distribute. So it says I capital R, plus I lowercase r equals E. Now again, we're solving for R. Here's our capital R. So anything without a capital R needs to be moved. So we're going to subtract IR. Subtract IR. And we have I capital R equals E minus I lowercase r. And then the last thing to do is to divide by I. So now you have R equals E minus I lowercase r, all divided by I. Or you can write this as E divided by I minus r. Both are correct. Okay, so this will conclude our video for 7.6. If you have any questions, feel free to send me an email